type that we're going to deal with is the general form. This is the y equals ax squared plus bx plus c form. And our example number 1, y equals negative 3x squared plus 6x plus 1, we want to find that vertex. And the way you find the vertex is using this formula right here. You might want to write this down and memorize it. It's x equals negative b over 2a. So that negative b over 2a is giving us the x coordinate of the vertex. So let's go ahead and do that. So we've got the opposite of b. So by the way, so this is a, b, and c, right? So ax squared plus bx plus c. Unfortunately, this 6 actually looks like a b, but that's just coincidence, right? So it's the opposite of b, so negative 6 over 2 times a, which is negative 3. So negative 6 over negative 6 equals positive 1. And if we take that 1 and we put it back into our equation, okay, for x, we can solve for the y coordinate of the vertex. Now remember, the parabola is this U-shaped graph, right? And the vertex is that point where it changes direction. So that's a key point on the graph. So if we take the 1, let's put it back in, we get negative 3 times 1 squared plus 6 times 1 plus 1 equals y. 1 squared is 1, times negative 3 is negative 3, 6 times 1 is 6, plus 1, so we get 7 minus 3 is 4, so you can see the vertex is going to be at 1, 4. Okay, so you're with me so far? So we're going to go right 1, up 4, that's our vertex right there, 1, 4. And the other thing you can do is, with this type here, the y equals x squared type, is you can draw a vertical line like this through that vertex. That's called the axis of symmetry, and it's going to be this negative b over 2a, in this case x equals 1. Remember, x equals lines are vertical lines. And so then at this point, now all we have to do is find some other key points, and I'm going to show you a couple different ways to find those key points. One way to find some key points is to look at this c value right here. Okay, the c value is the y-intercept, and the reason it's the y-intercept is because, you know, when you set x to 0, that's how you find the y-intercept. So by putting 0 in for x, it's going to cancel out these terms, and you can see that the y value is 1. Okay, so you can see here at 0, 1, we've got another point on our graph. And the nice thing about the axis of symmetry is if you reflect it over that line, you're going to get another point on your graph. Okay, now another technique that teachers will often show you is to focus in on this first part of the equation, the y equals ax squared. Okay, this is oftentimes referred to as the parent function, and it gives you the basic shape of the graph, like how wide it is or how narrow it is and whether it opens up or down. And then the whole equation is, going to be involved with shifting the graph up and down, left and right. But this first part is really going to be giving you the basic shape of the graph. Okay, so what you can also do is make a table, okay, like we started doing over here. But what I would do is just pick some small values like 1, 2, and 3. So if we put 1 in, 1 squared is 1, times negative 3 is negative 3. Now remember, you want to follow the order of operations. A lot of students will say negative 3 times 1 is negative 3 and then square it, and that's 9, but that's not correct. You want to follow your PEMDAS, your order of operations. Okay, if we put 2 in, we get 2 squared is 4, times negative 3 is negative 12. If we put 3 in, 3 squared is 9, times negative 3 is negative 27. But here's the key. You want to graph these points from the vertex. So you're going to pretend like this vertex is like your origin or your new starting point. So from here, I'm going right 1, down 3. That's this point here. Okay, we already found those. You can also go right 2, down 12. Okay, and so I'm just going to estimate. Let's say it's way down over here. If you take the mirror image over that line of symmetry, okay, this vertical line here, you're going to get the corresponding point. And then, of course, if I go right 3 down negative 27, that's all the way down to the floor, right? But in any case, you can see when I draw this, it's opening down. And we knew that because the a value here is negative. So when it's negative, that tells you that the graph is opening down. If it's positive, it opens up. And that's your graph. So let's look at another example. See if you can do this one on your own, and we'll go through it together. So example number 2, we've got y equals 2x squared plus 8x plus 6. So what do you think? How would you graph that? Well, first things first, let's go ahead and find the vertex. So negative b over 2 times a, right? So the opposite of b, remember this is b, this is a, this is c. So we've got negative 8 over 2 times a, which is 2. Negative 8 over 4 is negative 2, right? So we've got negative 2. Now we have to find out what the y-coordinate of the vertex is. So we're going to put negative 2 back in for x. So let me see if I can do that here for you. 2 negative 2 squared plus 8 times negative 2 plus 6. So negative 2 squared is 4, times 2 is 8, right? 8 times negative 2 is negative 16 plus 6 more. So we got negative 10 plus 8, which is negative 2. Okay, so our vertex is at negative 2, negative 2. So left 2, down 2. I'm going to draw that axis of symmetry, okay, right through the vertex. And then now what we want to do is find some other key points. So if we look at our C value, okay, remember our C value is this number here at the end. That's going to be 6. That tells us the graph's going to be crossing up here at 1, 2, 3, 4, 5, 6. And notice how I'm like 2 units from the axis of symmetry. So if I go 2 on the other side, I'm going to be at that same height, okay? Now, let's pick out some other values. Like say, for example, we make a table like this, x comma y, and I'm just focusing in on this parent function. So say, for example, I put 1 in. 1 squared is 1, times 2 is 2. So from this vertex right here, I'm going to go right 1, up 2, and I can do the mirror image over that line of symmetry. So now you can see we're getting a nice graph. It's opening up, which we knew that was going to happen because the A value is positive. When the graph opens up like this, you're going to get a minimum value. Okay, when the graph opens down like this one, you're going to get a maximum value, a high point. And that minimum value is just whatever the y coordinate is. It's negative 2. In this case, the maximum value is the y coordinate, which was 4, right? And then if they ask you for the axis of symmetry, that's this line right here. That's x equals negative b over 2a. In this case, it's x equals negative 2, okay? And that's basically it. The only other thing they might ask you is the domain and the range. And in this case, you can see the domain is whatever the x values can be, and it's going to the left and right, forever and ever. This is going up, but it's also expanding out like that. So the domain would be all real numbers. And then the range, those are the y values. So in this case, you can see the lowest that the y values can be here at negative 2 or higher. So that's going to be y is greater than or equal to negative 2. Okay, so this is your basic parabola. This is using the y equals ax squared plus bx plus c form, the general form. The next one we're going to look at is the intercept form. Okay, this next type of parabola that we're going to be graphing and working with is the parabola that's in this form, y equals a times the quantity x minus p times the quantity x minus q. And notice it's like in a factored form, and this is called the intercept form. And the reason is because if you set these factors equal to 0, you're going to be finding the x-intercepts, meaning where it crosses the x-axis. Okay, so the way to recognize this is it's in factored form. So let's look at example number 1 here of this type. You can see our a value is negative 1, and all that a value really represents is that the parabola is opening down. The larger the a value is, like if it was 2 or 3 or 4, it's going to stretch it by 2 or 3 or 4 times, which is going to make the graph narrower. Whereas if this was like a half or a third or a fourth, it would make it wider, right? But the negative 1 here is making it open down. And we'll talk about this in just a minute. But if we set these factors equal to 0, x minus 3 equals 0, x minus 5 equals 0, add 3 to both sides, right? And you can see that x equals 3, and add 5 to both sides here, x equals 5. Those are our x-intercepts. So let's go ahead and graph those. So 1, 2, 3, okay, and 4, 5. Those are our x-intercepts. Now what you want to do is you want to find the middle between those two x-intercepts. That's going to be your axis of symmetry. It's also going to be the x-coordinate of your vertex. So in this case, you can see that it's going to be right here at x equals 4. Okay, so I'll just write that down here, x equals 4. But if you want a formula, you can use this guy right up here, x equals p plus q divided by 2. So it's like an average. You would take the positive 3 plus 5, and you would divide that by 2. So that's going to be 8 divided by 2, which is 4. So you're just averaging those two values to get the middle. You're adding them up and dividing by 2. Okay, then you take that x equals 4, and you want to put it back in for x. Okay, so if I do that, I get 4 minus 3, which is 1, times the negative 1 in front. 4 minus 5 is negative 1. And if we multiply those together, you can see we're getting positive 1. So that tells us that that's our y coordinate of our vertex. So that's going to be at 4 positive 1, right? So right there. So already we have a pretty good set of points here. We can see our graph is looking like this. Okay, it's opening down. It's turning right at this vertex point 4, 1. We know it's a maximum, right, because it's opening down. But if you want to get some additional points, what you can do is a couple of different things. One thing is you can look at this a value, and we can kind of go back to what we were talking about at the very beginning of this lesson, the y equals ax squared. Okay, that's what gives us the shape of the graph. That's our parent graph. So in this case, our y equals negative 1x squared. That's the basic shape of our graph. And if we make a table, okay, and set some easy values in here, like 1, 2, 3, some small values, 1 squared is 1 times negative 1 is negative 1. 2 squared is 4 times negative 1 is negative 4. 3 squared is 9 times negative 1 is negative 9. But we're going to plot these points from the vertex. That's the key, not from the origin here. We're going to treat the vertex like the origin. So let's see, we've got right 1 down 1, right 2 down 4, 1, 2, 3, 4. And again, you can take the mirror image over the axis of symmetry, and same thing over here, right 3 down 9. It's kind of going off my graph. Usually your teacher, okay, is going to want you to have 5 points. So that's pretty good. We've got the vertex, the 2 x-intercepts, 1 additional point, and we reflected it over the the axis of symmetry. So that was a good problem. Let's try another one. See if you can pause the video and do this one on your own to check your understanding. So we've got y equals 2 times x plus 2 times x minus 2. Okay, so what do you think? Well, remember, the first thing is to set these factors equal to 0. So if we do that, x plus 2 equals 0, that would be negative 2. X minus 2, set that to 0, add 2 to the other side, that's going to be positive 2. So that means it's going to be crossing the x-axis here at negative 2 and positive 2. Okay. Now, if we use our formula, p plus q divided by 2, if we add these up and divide by 2, you can see we're getting 0 over 2, which is 0. So that means right here at 0, that's our axis of symmetry. Okay, that's the line, if you fold it over, the parabola is going to match to itself, like so. Right? It's a mirror image. Now what do we do with that 0? Well, we take that 0, that's the x-coordinate of our vertex. We put it back in for x here. So 0 plus 2 is going to give us 2. 0 minus 2 is going to give us negative 2. And we have a 2 out in front. Okay, I'm just bringing this 2 down. If we multiply those together, you can see we're going to get y equals negative 8. So our vertex is going to be at 0, negative 8. So let's see. 0, 1, 2, 3, 4, 5, 6, 7, negative 8. Now you can see we've got a pretty good idea what the graph is going to look like. We know it's opening up because the a value is positive. How can we find some additional points? Well, one way to do this is just to use the original equation. And we can say, well, we're kind of interested in maybe like this point right here when x equals 1. Just a little bit either side of the vertex. So say, for example, if I put 1 in, 1 plus 2 is 3. 1 minus 2 is negative 1. And if we multiply this out, we get negative 6. So over here we're at 1, negative 6. And if I do the mirror image across that line of symmetry, we've got another point. We've got our requisite 5 points, right? And you want to kind of round it out. You don't want it to make it look like a V. That's the absolute value graph. You want this to be more like a U. So I could have done a little bit better with rounding that out. But that's a pretty good sketch of our graph. So you can see it has a minimum value because it's opening up. That minimum value is the y-coordinate of the vertex, negative 8. The axis of symmetry is this line here. It's the line x equals 0. The domain is all real numbers, since you can see it's going left and right without bound. And then the range is the y values, and the y values are greater than or equal to negative 8. So this here was talking about the intercept form. We're going to go on next to the vertex form. Okay, so now we're looking at the vertex form of a parabola and how to graph that. So you've got the form y equals a times the quantity x minus h squared plus k. The vertex is at h comma k. Now the thing to remember with this form is that the number that's grouped with the x, that's in the parentheses with the x, that is going to have the opposite sign when you find the x-coordinate of the vertex. Whereas the k value is going to have the same sign. If it's positive, it's going to be positive. If this is like minus 2, it's going to be negative 2. But this one, if it was x minus 3, that would actually be positive 3. If it was x plus 3, then this would be negative 3. So you have to remember the one that's grouped with the x that has the opposite sign. So let's look at an example and you'll understand how this works. So this one here, you can see that the vertex is actually at positive 1. See, not negative 1, but positive 1. And this is the same, positive 6. So our vertex here is at 1 comma 6. So let's plot that. So right 1, 1, 2, 3, 4, 5, 6. That's our vertex, okay? Notice that the a value is negative. That means it's opening down like that, giving us a maximum. And if you want to find some additional points, what you can do is, again, just focus on that parent function, the y equals ax squared. And in this case, since a is negative 3, that's going to give us the shape of the graph. So I'm just going to make a table, pick some easy values for x, some small values. 1 squared is 1 times negative 3. 2 squared is 4 times negative 3 is negative 12. And the numbers are already getting large, so I'm going to stop there. But if I put 1 in, I'm going to treat the vertex like the origin, right? So I'm going to go right 1 from the vertex and down 3. And if I do the mirror image over this line of symmetry, right, it's going to be right here. Okay, and then over here, 2, negative 12, if I go right 2, down 12. I'm just going to estimate it somewhere down there, and I'm going to do the mirror image over the line of symmetry. So you can see this graph is going down fairly quickly here, okay? And that's the idea. Now, what makes it go down quick, by the way, is this A value. The larger this A value is, C3, it's stretching it, which makes the graph narrower, and that's why it's going down quickly. Of course, the negative means it opens down. We have a maximum, which occurs at our y-coordinate of our vertex at 6. That's as high as it goes. But if we're doing the domain and the domain is all real numbers. The range is y is less than or equal to 6. Okay, so great job on that one. By the way, also the axis of symmetry is x equals 1. That's that vertical line that, you know, divides the parabola in half. So let's go to example 2. See if you can do this one on your own, and we'll go through it. So what do you think the vertex is on this one? Okay, if you said -2, -5, you're right. Remember, it's the opposite of 2. That's -2. This one has the opposite sign, and this one has the same sign. So I like to plot the vertex first. So left 2, down 5. That's going to be right there. We draw our axis of symmetry like so. Okay, that's what divides the parabola in half. We take the parent function, which is the y equals ax squared. In this case, a is 4, so we're looking at y equals 4x squared. And we can plot some small numbers. So I put 1 in, I get 1 squared is 1, times 4 is 4, 2 squared is 4, times 4 is 16. But what I'm going to do is I'm going to go from the vertex. I'm going to go right 1, up 4 right there. I'm going to take the mirror image over that line of symmetry. I'm going to stop there. Normally I do graph 5 points, but the numbers are just getting quite large. So I'm just going to stop there. So you can see in this one we have a minimum because the a value is positive. It's opening up. That minimum value is at -5. The domain is all real numbers, and the range is y is greater than or equal to -5. So great job on that one. The last type that we're going to look at are these ones here, the x squared equals 4py and the y squared equals 4px. And we're going to understand those and look at the focus, the directrix, etc. Okay, our fourth and last type that we're going to be talking about are the parabolas that are in the form x squared equals 4py or y squared equals 4px. Now, a more general way to write these are like with an h and a k. And remember, the h and the k basically pick up the graph, shift the parabola left and right or up and down. The one that's grouped with the x will shift it in the x direction, right, the horizontal direction. The one that's grouped with the y will shift it in the vertical direction, the y direction. But remember, it's going to have the opposite effect. So the one that's grouped in parentheses with that variable is actually going to shift it the opposite. So if it was y minus 2, a lot of students think -2 are going to shift to the left, but you're actually shifting right 2. Okay, so just remember, the number that's grouped with that associated variable has the opposite effect on the graph. So let's look at the first example, and I'll kind of go through it as we do this. But actually, before we do that, let's take a quick look at the basic shape of a parabola. We know it's that U-shaped graph, right? But when it's in this form, what we're looking at and we're focusing on is a couple different things. We're focusing on the vertex, of course. That's the point where the parabola changes direction. We're also focusing on the focus. Okay, that's this point here. And then this imaginary line here called the directrix. And the idea here is that if you pick any point on the parabola, okay, so say for example, this parabola is going out like that. Say I pick a point right there on the parabola. If I measure the distance from that point to the focus, and then from that point perpendicular to the directrix, those distances will always be the same. So as you go further out, of course, the distance to the focus is going to get further, but then the distance to the directrix is also going to get further, and those distances are always going to be the same. So technically what a parabola is, it's the set of points that are equidistant from a given point called the focus and a given line called the directrix. Okay, so it's a mouthful, but let's see if I can break it down and kind of show you how this works. So in the first example, x squared equals 12y, right? So what I want to do is I want to match it up against this form right here, x squared equals 4py. So I can set 4p equal to 12, divide both sides by 4, and I can see that p equals 3. Now, because this parabola hasn't been shifted at all, see the h and the k are 0, that means that our vertex is going to be at the origin 0, 0. Okay, so you're with me so far? Now, because it's an x squared variety, x squared ones are going to open up or down. If it's a y squared, it's going to be opening to the right or the left. Okay, so you want to remember x squared up or down, y squared left or right. Okay, so in this case, because p is positive, it's going to be opening up like this. So I'm going to go from the vertex up 3, 1, 2, 3. That's going to be our focus. And if I go down 3, 1, 2, 3, that's going to be our directrix. And you can kind of think of the directrix like a deflector, like it's deflecting the parabola, like it's going this way and it's deflecting it, okay? So it always opens away from the directrix towards the focus, okay? So notice that this p distance, this focal distance, is the same from the vertex to the focus as it is from the vertex to the directrix. Okay, so now we need to get some other points on our graph to get a nice parabola graph. And the key here is that the width, okay, this is called a focal chord, this width, at the level of the focus is going to be 4 times p wide. Okay, we said that p is 3, 4 times p is 12. So at the level of the focus, it's going to be 12 wide. What you can do is cut that 12 in half. From the focus, go right 6. Let's see, 1, 2, 3, 4, 5, 6. And left 6, 1, 2, 3, 4, 5, 6, like that. So that gives us a width of 12 at the level of the focus. Of course, the parabola is getting wider and wider, you know, as it goes, right? But at this height here, at this focus level, that's how wide it is, it's 12. So that'll give you a pretty good idea of what the graph is looking like right there. Now, if they ask you for the equation of the directrix, you can see that this is a horizontal line. That's a y equals line. It's y equals -3. We know the coordinates of the focus, and we know the vertex. So we've got a pretty good sketch there. Okay, let's look at another example. Let's look at a y-squared variety now. So y-squared tells us it's opening to the right or the left, right? This way or this way. It's negative, so that tells us it's going to open to the left. If it was positive, it would open to the right. We want to find our p-value, so we're going to set 4p equal to -16, divide by 4, p is -4. You can see that it hasn't been shifted at all. Our h and our k, right? Our h and our k are 0, 0, because it hasn't been shifted. You don't see it, you know, anything in parentheses grouped with the x or the y. This should actually be x here, okay? There's a typo on my part. Okay, so now you can see the vertex is going to be right here at the origin, okay, 0, 0. And we said it's opening to the left, so we're going to go 4 to the left, 1, 2, 3, 4. Okay, that's our focus, that's our vertex. And if we go the other side, 4, that's our directrix right there. Okay, it's deflecting the parabola in a sense. It's opening away from the directrix towards the focus. And then at the level of the focus, it's going to be 16 units wide. So from the focus, I'm going to go up 8 and down 8 to give us that width of 16. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. And then down 1, 2, 3, 4, 5, 6, 7, 8, right about there. So that gives us an idea about how wide our parabola is. We know it's opening to the left because of the negative. Y-squared variety opens left to right, but left because of the negative. This one here was x squared, okay, so it was opening up or down, up because p was positive. And the only thing they might ask you is, you know, what's the axis, they might ask you the axis of symmetry, which is actually this line right here. This is the line y equals 0. If you fold the parabola over the x-axis, it's going to match to itself. But remember, the x-axis is actually the line y equals 0. But the directrix, this equation would be, it's a vertical line, so it's going to be x equals 4. And that's basically about it. They might ask you the domain and range. Domain is going to be x is less than or equal to 0. Remember, the domain are the x values, so less than or equal to 0. But the graph is going up and down, so the range would be all real numbers. Okay, a little bit more challenging one. This is our last example. This one, what do you think? Okay, quick quiz. Do you think it's going to open up, down, left, or right? Well, notice it's x squared, right? The y isn't squared, it's the x is squared. That tells us it's going to open up or down, right? Okay, but 4 is positive, so that means it's going to open up. If this was a negative here, it would open down. So let's locate our vertex. Now notice the number group of the x. That's the x coordinate of the vertex. The one group of the y, that's the y coordinate. Okay, you don't want to confuse those. It's pretty easy to remember. Whatever's with x is the x, whatever's with y is the y. But remember, they're the opposite signs. -2, see, x is positive 2. Positive 1, the y coordinate is -1. So right 2, down 1, that's our vertex. Sometimes I like to just label it with a V or an F for focus or D for directrix. And we know it's opening up. Now this value here, we have to set equal to 4p. So if we divide by 4, p equals 1. Remember, it's in this form right here, right? So you can see 4p equals 4, p equals 1. So because it's opening up, I'm going to go up 1, that's our focus, down 1, that's our directrix, okay? And then remember, at the level of focus, how wide it is going to be 4p. In this case, 4p is 4. So at the level of focus, I'm going to go right 2, and left 2, that gives me the width of our parabola, and we have a pretty good sketch at that point. Now, if they ask you for the axis of symmetry, that's the vertical line here that divides the parabola in half, right? X equals 2. The directrix is this horizontal line here that's kind of deflecting the parabola in a sense. It's opening away from the directrix. That's the line y equals -2, and you've got it. So we went through a lot of different types of forms of the parabola. I'll have links in the description below to other videos I did specifically talking about some of these different types if you want more practice, more experience, and that sort of thing. And I also want to mention, if you're preparing for the ACT or the SAT, which I know a lot of students are, check out my huge ACT math review video course and my huge SAT math review video course. I'll have links in the description below. You can check those out. There's free lessons, so you can get some benefit from those, and if it's a good fit for you, you can check out those courses. A lot of students have taken them, and they've benefited them when they've taken the tests, and I'm sure they'll benefit you too. And that's about it. If you have any suggestions or comments for me, put them in the comments below. Otherwise, I look forward to helping you in the future videos, and I'll talk to you soon.